Test 2.6 is going to have us graph exponential functions. We have two different types of exponential functions. We have exponential growth and we have exponential decay. The biggest difference between growth and decay is our growth graph is going up from left to right. Notice it's increasing. Where our decaying graph from left to right, it's going down or it's decreasing. The way to tell the difference between growth and decay within our function itself is to look at the base or the b value, the number that's being raised to the x. If we have a growth function, b is going to be a number greater than 1. And if it's a decay function, b is going to be greater than 0, but less than 1. The other two parts of the equation are the same for both growth and decay. A is going to be any number except 0 in both cases. And it has what we call an asymptote at y equals 0. An asymptote, which is defined below, is a line that a curve approaches as it heads towards infinity. So as you're looking at this exponential growth graph, as we go to the left, our graph is going to get very, very, very close to that line y equals 0 or the x-axis, but it will never cross over and it will never touch. Same thing here with our exponential decay graph. We can see that as it's moving to the right, it's getting very close to that x-axis, but it actually will never touch the x-axis or cross over it. Okay, because it's getting very close to this line, we call that an asymptote. Next, in question number 1, we're going to go ahead and graph a function. So in number 1, it says use your graphing calculator to complete the table below and sketch a graph of the function. So I'm going to open up a video here of my graphing calculator so that you guys can see it as we're working through it. So right here is the graphing calculator, and this should look very similar to what you have either on your Chromebooks, or if you're in the classroom, you might have a classroom set of this calculator. Okay, it goes all the way down to here. The very first thing you want to do is make sure your calculator is turned on. So there's the on button at the bottom left. So go ahead and click that on button if it's not on. And what we want to do is we want to enter this function into our calculator. So in order to enter it, we need to go to the y equals button. The y equals button is the one I'm pointing at right now with my thumb. So it's up on the top. So I'm going to hit that y equals button. And if there's anything in there, just go ahead and clear it out. So you want it empty. And every once in a while, we get stuff that's in the bottom of our calculator. So sometimes it's nice to scroll down. So using that down arrow key right here, we can scroll down and check all our different y equals just to make sure there's nothing written inside. Once everything is cleared out, then we're going to plug in our function. To plug in the function, we want to start with the 3. So we'll enter the 3. Then we're going to use our multiplication button, times, and then 2. And then the exponent key is the next one. The exponent key is actually right above the division sign. So here's my division sign. Right above the division sign is my exponent key. And you'll see as I push that button, my cursor now goes up to the top, indicating that I am in that exponent. And I want it raised to the x. My x, or my variable key, is going to be directly to the right of the alpha key. So the alpha key is right here. Directly to the left of it is this button right here. I'm going to click that button as well, and we'll see we have 3 times 2 to the x. Next, what we want is we want to be able to see the table. So if I take a look at the top of my calculator, I have my gray buttons, my y equals, my window, my zoom, my trace, and my graph. And above those are some words in blue. To get to the words in blue, you need to hit the blue second button first. So this blue second button will take us to any of the buttons above. So if we notice, the table is above the word graph. So since table's in blue, I'm going to hit the blue second button first, and then I'm going to hit the graph button. And it's going to take me to a table. In this table, we can scroll up and down using our arrows. So we have our up arrow and our down arrow, and we can scroll up and down to find the numbers we need. For instance, in the table, our very first number we need is -3. Notice -3 is not in the screen that I have on my calculator right now. So I can hit the up arrow key and my table will move until I find -3. So right now I have -3 for x. If I scroll to the right, I get the y value that goes with it, which is 0.375. So then I can go ahead and write in my table that negative 3 goes with 0.375. Then I also need negative 1, so I can scroll down to negative 1 using the down arrow key and check the y value that goes with it is 1.5. So I can fit 1.5 on my table. Then I can go back to my x's, scroll down to 0, and I see 0 goes with 3, so I can fill in 3. Then I go down to 1, and 1 goes with 6, so I can put 6 in my table. And then if I scroll down to 2, I can see that I have 12. So now that I have the numbers on my table, I can go ahead and graph them. So I'm going to come to my graph, and I'm going to plot those points. My decimals are going to be approximations, so notice that I have the point negative 3 and 0.375. So I'm just going to approximate that. So I'm going to go to negative 3, which is here, and 0.375 is going to be a little less than halfway to 1. So I'm going to plot that point right about here. Then I have the point negative 1, 1.5. So I'm coming to negative 1, and I'm going to go up to 1.5. Then I have the point 0.3, so we'll plot the point 0.3. We have the point 1 and 6, and we have the point 2 and 12. One thing I want you to remember is we do have that asymptote at y equals 0, so I'm going to put that asymptote in. When we graph it as a dotted line. So our asymptote is this dotted line on our x-axis here because it's y equals 0. So our graph will not cross over that x-axis. So it's going to come around this way, and then it's going to come up on an angle to the right.